Hi guys, welcome to another video, and in today's lesson we're looking at momentum. Now momentum is a term that we give for any moving object. Any moving object will have momentum. The bigger the object's momentum, well, the harder it is to stop that object from moving or perhaps change its direction. We can define momentum using the following equation, where P represents momentum and the unit for momentum is kilogram meters per second. This is mass, and mass is measured in kilograms, and V is velocity, and that's measured in meters per second. You could be asked in your exam to calculate the momentum of an object. But before we do that example, again I want to show you guys how to rearrange this momentum equation. It tells us that mass times velocity, so mass and velocity would go at the bottom of this triangle and momentum would go at the top. Also from this equation we can assume that the bigger an object's mass or the bigger its velocity, the more momentum that object will have. What about this? Let's say I've got a ball and this ball has a mass of 2 kilograms and it has a velocity of 5 meters per second. And the exam asks you to calculate the momentum of this ball. Well, it would be quite easy because we just write out our equation, and you can see that I don't need to rearrange this equation because I can plug the numbers straight in to get momentum. Mass is equal to 2 kilograms and velocity is 5. So typing that into my calculator, 2 times 5, it gives me a momentum of 10 kilogram meters per second. Now, there is a law of momentum, or a law of conservation of momentum. And what that law states is that in a closed system, the momentum before an incident is exactly the same as the momentum after the incident, as long as it's a closed system. Well, let's put that into practice, because you could be given a closed system to calculate the missing quantity. So on the board here I've drawn an example of a car crash. This is before and this is after. The information that we know before the car crash are the masses of the two cars, and we also know their velocities. After the collision, I only know their mass, and we are expected to be able to calculate the velocity. So how would we do this? Well, first of all, let's calculate the total momentum before the incident taken place. Now, the total momentum would be the momentum of car A added to the momentum of car B. Well, the momentum of car A is just its mass times velocity, so 100 times 2, and that's 200 kilogram meters per second, and we're going to add that to the momentum of car B. Well, the momentum of car B is its mass times velocity, 200 times 0. If an object's stationary, it will have a velocity of 0, which means its momentum will also be 0. So the total momentum before the collision was 200 kilogram meters per second. Which means the total momentum after the collision must also equal 200 kilogram meters per second. Well, let's have a look at what quantities we've been given. We know the mass is 300 kilograms because the two cars have crashed together. So we just add their masses, 100 plus 200. That gives us a mass of 300 kilograms. But we don't know the velocity that both of these cars are now moving. So we write our equation. Momentum is equal to mass times velocity. And we want to calculate the velocity. So, looking at my equation, it's momentum divided by mass. So momentum is 200 because it doesn't change before or after the incident. And the mass is 300. So in my calculator, I would type 200 divided by 300, which will give you a velocity of 0.67 meters per second. Guys, please check out the website where you can get more examples of calculations for you to have a go at. Okay, thanks for tuning in and stay in touch for another video.